Hi, I'm Matthias, the director of SeRo Systems, a startup based in Germany, in Kaiserslautern. We've built the hardware and software to monitor the radio frequency that is being used for communications between aircraft and the ground infrastructure and other aircraft as well, for collision avoidance. In aviation, technologies need to be backwards compatible, so you basically end up having the weaknesses in terms of cybersecurity from very old technologies, and you cannot really implement what you know from other wireless networks like Wi-Fi, for example. So one part of this transition to digitalization is a switch from ground-based air traffic surveillance, where you use radar to localize aircraft, to a more decentralized approach called ADS-B. ADS-B is very simple, so aircraft are equipped with GPS receivers and they simply digitally broadcast their positions. All of this is unencrypted, and this brings one major challenge into the game, which is that now, instead of trusting the ground infrastructure that as an ANSP, for example, you control yourself, now you have to trust thousands of aircraft. So we came up with the idea to have a system on the side, a monitoring system, which basically monitors physical characteristics of the radio signals from transponders, and by doing that we can basically detect whether the information provided by the aircraft is correct or not. One incident that happened was, for example, in 2014 over Europe, where several aircraft disappeared from the radar. After a huge investigation, they found that a set of aircraft which were equipped with a certain transponder were over-interrogated by a radar manufacturer in the Czech Republic, which was running their radar in a test mode, and its behavior was kind of anomalous, and there was a bug basically, and it over-interrogated those transponders, and the transponders basically overheated and shut down. It didn't respond to anything anymore, so these aircraft disappeared from the screen, which is the worst case that can happen in air traffic surveillance. And these things can be detected as well by simply monitoring what is the transponder actually doing. How often is it transmitting something? Is it transmitting at an enormously high rate? So these are the very simple anomalies, but you need to have a very accurate and very sensitive ground-based monitoring system to actually detect these things. And that's what we've built basically.